Okay, this is 1-2 Part B notes, covering quadratic and square root functions. Again, the characteristics of a graph are domain and range, x-intercept and y-intercept, maximum number of roots or zeros, the places where the graphs cross the x-axis or touch the x-axis, in behavior, and whether they're continuous or discontinuous. At the ends, making them going to infinity. So the function equation is f of x equals x squared. The domain is all real numbers, excuse me, as x goes to negative infinity and x can go to positive infinity. For the range, we start touching the graph at 0 and it goes to positive infinity. So the x-intercept is at 0 and y-intercept is at 0. So the origin is the x-intercept, y-intercept for the quadratic parent function. We also call that the vertex or the inflection point. Vertex is the main word we use for quadratics. Maximum number of zeros is 2. That means if we move this quadratic equation down by even one little notch, it will touch the x-intercept at max 2 places. And behavior is as x goes to negative infinity, the y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. And it is a continuous graph. This graph has the same attributes of what other graph that we've talked about. So what is the parent function equation for this graph? It is f of x equals x squared. What is the domain of this graph? It is all real numbers. And what is the range of this graph? It is -4 to y is greater than -4, or -4 to infinity. How do we know? Well, it changed. Even though it moved left to right, the domain won't change because it was all real numbers. But when it moved down, that changed my range from y is greater than or equal to 0 to y is greater than or equal to, first place I can touch it is at y is -4. A square root parent function is the second equation or function that we'll look at this time. It is a special one because it does have a restricted domain and range. The function equation is f of x equals the square root of x. The domain starts at 0 and goes to infinity. The reason for that is because you cannot put a negative number under a square root and get a real answer. So to be real, we have to keep all the x's positive. But you can put 0 under there, so that one's fine. The range, because the x's are restricted, so are the y's. The only answers you can get are positive f of x. The x-intercept is at x is 0. The y-intercept is y is 0, which makes the origin the inflection point. The domain is the maximum number of roots that you can get on this one is 1. So we can move this parent function left, right, up, or down, and the only time it will only cross that x-axis in one specific spot at most. And behavior is as x moves to 0, y will also move to 0. It won't go less, it won't go more. As x goes to positive infinity, the y will also go to positive infinity. And it is a continuous graph. So which of the following represents the domain of the square root of x? If you chose B, you'd be correct. Again, this is set notation. So what I showed you on the note part was the interval notation, and this is set notation, where it says x such that x coming from all real numbers, all you can choose is x is bigger than or equal to 0. And when y is coming from all real numbers, all you can choose is y is bigger than 0. Okay, what is the domain of this function? If you chose x such that x is greater than or equal to 0, you're right. What is the range of this function? If you chose y is greater than or equal to 0, you'd also be right. Now, even though it's moved to the left, it didn't change its range. It's only when it moves up or down that it will change its range, and if it moves left or right, it changes its domain.